Hi, and welcome to Revolt Power. Today we're going to be talking about a technique to add battery posts to batteries that don't come with them. There are some battery packs, primarily out of hybrid or electric vehicles, that come with either welded on or soldered on terminal wires that don't really lend themselves well to being converted for aftermarket use, like as a power wall or as another DIY project. So I'm going to reach back into the kind of ancient history tomes, and I first saw this technique demonstrated by my grandfather, Pat Sr., almost 40 years ago. He used this technique to weld studs into the bottom of an aluminum fishing boat. And to give you an idea how difficult this was, nowadays welding aluminum is still very, very difficult. It's a very specialized knowledge, usually done with TIG welding, tungsten inert gas, or a number of other specialized techniques. But this man was such a talented welder that he could do it with an arc welder using sticks.
Dead for almost 20 years. Still taking me to school.
So we're going to kind of pause it. I'm going to go over to the bench and show you the basic technique. But before I do that, you're going to need some tools. You are going to need a wrench, something adjustable. This is the Blue Point / Snap-on. It's a version of the channel locks, but it's for nuts. You're going to need a hole punch. 3 to 4 millimeter is usually good. This one's a 5, but it's all that I could find locally. I've modified it a little bit. I took off the paper ejector and the little collector point on the bottom. You're going to need a screwdriver. This one's a flat tip. You need a clamp or some forceps. I like locking forceps. They give me a lot more control, but if you don't have them, one of these little plastic clamps can be used as well. You are going to need a supply of aluminum, or excuse me, nickel strip, and you're going to need some scissors. You'll also need a battery spot welder, and you're going to need an assortment of brass machine screws, each one with at least 2 nuts. Alright, so let me get set up, and I'm going to show you how to get prepared and get everything together to be able to do this and replicate this technique for your battery project. So looking here, we've got 2 different setups. We've got a real battery. This is a lithium titanate battery out of a Honda e-bike, and you can see that it's got a couple of areas where I was creating basically terminals by cutting part of the aluminum apart and then basically making a little spade connector and turning it up. It's very, very difficult to do, and a lot of them ended up breaking off, or just, they were so delicate because this is such thin metal. This is probably 20 thousandths thick. Fairly heavy as bus bars go, but still very, very light gauge to work on. There's going to be 2 videos in this series. The first one's going to be dealing with ferrous or other types of nickel or plated steel type batteries, like you would see at the top of an 18650 or so forth. And let me adjust this just a little bit so I can see what I'm doing. And then in the second video, we'll discuss how to tackle these ones with aluminum, because you cannot spot weld nickel strips to aluminum base. So I'm going to show you how to do it in video number 2. So keep your eyes out for that. It will be coming. But let's set this aside for the moment. And let's concentrate on this. It's a fake battery. We're pretending this is a battery, but the technique works exactly the same. It even says on there, fake battery. I've got a couple different types of nickel here. These are all verified, 99% pure real nickel. They range from 15 thousandths in thickness and 10 millimeter for these 3. This is 10 thousandths in thickness at 8 millimeters wide, And this is really tough. I'm going to say that this is 20 thousandths of an inch thick and 4 millimeters wide, but this is free. These actually come when you have those little white tabs that come out of anti-shoplifting packages. If you cut the end off, this is pure nickel strip, and it's in each and every one of them. Every one of them has 2 pieces of it in it. So this is what we're going to start with. So I already have some cut, but I'm going to take my scissors. I'm going to cut 3 strips, about 18 millimeters, maybe closer to 20. It's about 1.5 inches. I'm going to kind of flatten them out as you work there. Okay, we're going to take our 10 millimeter wide nickel and we're going to set it aside. Once we've done that, we're going to take our hole punch, the hole facing up, so we can approximately figure out. It may be easier in some cases if you have enough room to get a good alignment by going on endwise. Let me get that there. Now I know that I'm pretty much centered until I drop it. These are spring loaded. And all I'm going to do, that's not quite where I want it. There we go. Oh, get it in there. And this is kind of tough. We're going to punch a hole. You may have to pop these back open. Now, this is what I've got. I have a piece of nickel. It's got a little bit of wrinkle in it. That's okay. With a hole very, very close to the center. I'm going to set that piece down. And take the end of my screwdriver and I'm just going to kind of rotate it a little bit. That'll flatten that back out without hurting it. There we go. Nice and neat. So I got 2 more I got to do. Again, this is kind of tough. If you got to do a whole bunch of different batteries, you may find this to be very time consuming. But if you don't have a choice to get a battery terminal on it any other way, I keep forgetting about that spring loaded bit. And that one perfectly spit it out at me. Again, when we take it off, we want to be really careful because this stuff will tear. Ooh, that's pretty. Got 2. Get our 3rd one. Going to kind of line it up here. Okay. And that one's not quite as centered, but it's not bad. So again, we're going to take our screwdriver handle and kind of flatten that out. Now we're going to set these aside. 1, 2, 3. We are going to take our brass. These are all brass, by the way. Take our brass screw and a nut. We're going to grab our pliers, our wrench. We're going to clamp down nice and tight on that. Grab our screwdriver. What we want to do is go ahead and tighten that screw up and get that screw nice and tight against the base of that nut. There you go. So this is what we basically end up with. See if we can get a little bit of focus there. Nice. Okay. So at this point, we're going to take our nickel strips and we are going to just set them down. 1, 2, 3. And here's where our forceps come into play. Take our forceps. We're going to line these up nice and neat. Just like that. So that they're all parallel to each other. And get our second nut. Sorry if my hand's in the way there. Okay. So our second nut, we're going to do the exact same thing. We're going to hold our nut. And again, tighten that down. Let's see if I can get it back in there. Good. Now we've got a nice solid clamped surface. Should be fairly much in line. There we go. Now it's easier. Let me use the tip of my screwdriver to point this out. If this flat surface is perpendicular to this. So what I want to do, I'm going to use my pliers to hold the nickel nice and flat, just like that. And I'm just going to turn that nut just a little bit. You have to remember, we are dealing with brass, so it's very, very soft. Alright, there we go. Now, at this point, we're going to take our scissors and we're going to cut these so that they're even, nicely trimmed. This one's actually pretty close on both sides. So this is what the final assembly looks like. Very, very straightforward. And what we're going to do at this point is we're going to bend our first one down, just like this. And then we're going to bend our second two up. And that's what it should look like. So once you've got that, if you're working with a bunch of batteries, you may end up making, 4, 8, 10, 12, however many that you're going to need for this. So once we take this first one, we're going to slightly bend out that very first layer so that it's got wings like that. Okay. Cool. Now, all we've got to do at this point is I'm going to move my tools and my spare nickel strip aside. Set them over there. Now, put these over there. As David Letterman used to say, for my next dumb pet trick, I'm going to take my welder and plug my leads in. I'm going to turn it on. It's already set to automatic. But what we're going to do is we are going to center this on our base. Imagine this is the top of a battery that needs a post. We're going to go 1. And we're walking towards the post, making it tighter and tighter. So you'll see I've got 6 in there. This is really hard. But we end up with 8 welds. Hold that up so that you can see it. Now, we're just going to kind of line this up, and we're going to do the exact same thing on the other side. You can press in towards the base, get that really good solid connection. 2, 4, 6. I got a really tight space here. 8. So that's how it should look. Now, we're going to take our second wing. Again, remember, this is very thin metal, so it's subject to fatigue. The more times you bend it, the more times it's likely to break. At this point, we're going to grab our screwdriver. I'm going to try and illustrate this, but we're going to push that metal in as tight to the base as we can get it without hurting it. I'm going to turn it around, do it from the other side as well. Now this one's a little bit shorter because we're coming down from a higher point. 2, 4, 6, 8. Turn it around. Again, I'm going to start from the inside out here, pushing it towards it. 2, that weld did not take, so I did it again. Okay, so now we have our second layer. Make sure that's getting a little bit of close up there. Now we're going to bend down our third layer. And again, using the exact same technique, we're going to use the screwdriver. We may have had a weld break. We did indeed. So I'm going to bring this back up, noting that I don't want to bend it any more than absolutely necessary. My battery's still charged, so I don't think this is a battery issue. There we go. That time it took. Alright, go back with our screwdriver. As long as you've got plenty of nickel strip, this is not an expensive repair to make. If you get one that goes bad, it's not the end of the world. So again, we're going to press in towards that base as much as we can. 2, 4, 6, but I don't like that one, so I'm going to do it again. Okay. Ooh, that's pretty. Now, I'm going to come over here to the other side. Do the exact same thing I did on the first side. We're going to go 2. We're going to hit it again because I don't like that one. Okay. Now, what you'll see, and this is going to get hot, but now I've got great contact between the brass post and the initial welding surface. And not only is that a conducting point, but I've got it clamped in between these two nuts as well. So that's a secondary conducting point as well. So once you're done, let it cool off, rinse, repeat, and you can do this as many times as you like. And there's nothing to say, for instance, let me pop a piece real quick here just to demonstrate. If you have a situation where you're not comfortable with going linear in one direction, I don't have it here, but we can demonstrate it. There's nothing to say that you can't go the opposite direction as well. That piece is kind of jacked up, so it broke. But you could do this in any axis that you need. So you're not limited by a given, all you need is surface area. So if you've got enough surface area, and you can see this actually only requires a little less or a little more than 1 1/8 total. So you don't need on a lot of these big battery packs, it's not unusual for there to be a welded or soldered terminal post that's 1.5 to 2 inches square. So this is actually a really super easy technique. Once you get to this point, you can simply add your terminal and wire, Make sure that you're holding onto this so that it can't turn. You can also, using a Dremel tool, slot the end of this and put a screwdriver in to keep the screw from turning as you tighten down this nut. Generally it's smarter, I would say, to use a lock washer of some type, either the serrated types or in some cases the spring-loaded types, so that you're not putting a lot of end pressure on that soft brass post. Anyhow, that's the technique. Simple as anything. Go ahead and move this up. Stay tuned. There's going to be a part 2 to this where we talk about basically recreating this process, but on a battery that's got an aluminum top, which is a much different proposition. Because despite what people tell you, nickel is indeed magnetic. There are many YouTube videos showing people with 99.9% pure nickel sticking straight to a magnet. So don't let anybody tell you that it's not real nickel because a magnet sticks to you. That's just a myth. So that's everything that we've got for today. So come back for part 2 and hope that you've learned a little something and a new technique today. And huge shout out to my grandfather, Pat Sr., for teaching me this in the first place. I would have never thought about this had I not seen this as a little kid.